Last summer, my family and I visited Russia. Even though none of us could read Russian, we did not have any trouble in figuring our way out, all thanks to Google's real-time translation of Russian boards into English. This is just one of the several applications of neural networks. Neural networks form the base of deep learning, a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Neural networks take in data, train themselves to recognize the patterns in this data, and then predict the outputs for a new set of similar data.
Neural networks are algorithms that are based on the way the brain works. They can build predictive models by learning the patterns in historical data. Neural networks are made up of small, interconnected processing elements. These elements are called nodes. Each node processes a small part of the task. The most common type of neural network is called a multilayer perceptron. In a multilayer perceptron, the nodes are organized in layers. The first layer is called the input layer. The outermost layer is termed the output layer. Between these two come one or more layers. These are called hidden layers. The input layer receives the values of the independent variables as input. The nodes of the hidden layer take their inputs from the input layer, process it, and pass it on to the nodes of the output layer. This is what happens within a node. A node receives information from multiple nodes of the previous layer. These are multiplied by unique weights and added together with a small value called a bias. This total is processed by a function called the activation function and leaves the node as output. This process proceeds till information reaches the output layer and leaves it as a prediction for the dependent variable. The network then compares the prediction with the actual value of the dependent variable. If these do not match, it adjusts all the weights in the network and repeats the process. These iterations get repeated till the neural network is able to produce accurate predictions for most of the observations. Once this is achieved, we are left with a neural network model that can be applied to a new set of data to provide predictions.
You might wonder how long this training process takes. Honestly, neural networks may take hours or even months to train. But time is a reasonable trade-off when compared to its scope. Let us look at some of the prime applications of neural networks. Facial recognition. Cameras on smartphones these days can estimate the age of the person based on their facial features. This is neural networks at play, first differentiating the face from the background and then correlating the lines and spots on your face to a possible age. Forecasting. Neural networks are trained to understand the patterns and detect the possibility of rainfall or a rise in stock prices with high accuracy. Music composition. Neural networks can even learn patterns in music and train itself enough to compose a fresh tune. With deep learning and neural networks, we are still taking baby steps. The growth in this field has been foreseen by the big names. Companies such as Google, Amazon, and NVIDIA have invested in developing products such as libraries, predictive models, and intuitive GPUs that support the implementation of neural networks. The question dividing the visionaries is on the reach of neural networks. To what extent can we replicate the human brain? We'd have to wait a few more years to give a definite answer. But if you enjoyed this video, it would only take a few seconds to like and share it. Also, if you haven't yet, do subscribe to our channel and hit the bell icon, as we have a lot more exciting videos coming up. Fun learning till then.